Now that we are familiar with all of the different factoring methods, we can use factoring to help us solve quadratic equations. There's several methods for solving quadratic equations. Factoring is just the first one that we're going to look at now that we know how to factor. So let's look at our key terms. 3x squared minus 5x plus 3 equals 0 is an example of a quadratic equation. What makes it a quadratic equation is that it starts off with a squared term, and the highest exponent we see is that squared. We've studied linear equations. That just would have been a negative 5x plus 3. They wouldn't have that squared term. So once you put a squared term in, it is now a quadratic equation. Number 2, the principle of zero products states that a product is 0 if and only if one or both of the factors is 0. Now this is something you've known for a very long time. You know that if you have two values, we'll just say A times B, and you multiply them and you get 0, then what does that tell you? Well, either A has to be 0 or B has to be 0. One of the numbers or both of them have to be 0. We're going to use that idea to help us solve here in a minute. To use the principle of zero products, you must have 0 on one side of the equation. And the last one, to use the principle of zero products, we factor a quadratic polynomial. So now let's look at how we can apply the zero product property to quadratic equations. Now the first thing you're going to notice is we have equations. We haven't seen equal signs in a while, so that's new. And both these examples are in what we call factored form. So it's not a trinomial that we have to factor. It's already factored for us. So in the first problem, we have 0 equals x times x minus 8. Well, because of the zero product property, because some value times another value equals 0, then that tells us either A is 0 or B is 0. So when you're solving a quadratic equation by factoring, the first thing you have to make sure is that it's equal to 0. Then you have to make sure it's factored. So what we do then, set each factor equal to 0. So that's the key. Set each factor equal to 0 and solve. So since the answer is 0, that means either x equals 0 or x minus 8 equals 0. So it looks like we already have an answer here, x equals 0, and all we have to do here is solve this little mini equation to find my other answer. Yes, this particular problem has two answers. So either x equals 0 or x equals 8. If I plug in 0 in for x into my original, I'm going to get 0. If I plug 8 into my original, again, I'm going to get 0 because 8 times 8 minus 8, 8 minus 8, 0, which makes the whole thing 0. So there's two answers. So depending on how many factors you have will determine how many answers you have. Okay, so let's look at this next one. Again, it's equal to 0, so we know that we can use the zero product property, and it's already in factored form. So we have to set each factor equal to 0. So either 4x plus 3 can be 0, or 2x minus 10 can be 0. So now we solve. So I get 4x equals negative 3. Divide both sides by 4. So my first answer is going to be x could be negative 3/4. On this one I would add 10. Divide by 2. And x equals 5. So 2 answers, and again, you can always check them by plugging in. If I plug in the 5 into the second factor of 2x minus 10, that's 2 times 5, which is 10, minus 10, 0, makes the whole thing 0. And you can plug in the negative 3/4 into the first one, and you're going to get 0. So again, make sure your equation is set equal to 0, and it must be in factored form. So what happens if it's not in factored form? Or what happens if it's not equal to 0? So let's look at the first one on this page. We have number 14, x squared plus 4x minus 21 equals 0. So we've got the equal 0 part, so we're good there. But it's not factored, so guess what we have to do? We have to factor. So that is going to be the key to all of these, is you must factor. So let's put some of our factoring skills to practice. We have a trinomial. Is there GCF? No. So now it'll probably break down into 2 binomials. Factors of x squared, well, that'd be x and x. My second sign is a minus, which tells me my signs are different. So I have options for 21. I have 1 times 21, and I have 3 times 7. We need factors of 21 that could combine for 4. Well, 3 and 7 will make that happen. And then this is how I decide on my signs. If I do my outers, I get 7x. If I do my inners, I get 3x. In order to get 4, my 3 has to be negative, and my 7 has to be positive. So it'll be negative 3, positive 7. Remember though, not only do we factor, we have to factor first. That's the first thing we do. Then we set each factor equal to 0. And solve. So many students stop after they factor, but you're not done. So now that we have factored, I'm going to get rid of my check step here so I've got a little bit more space to work. Now I have to set each factor equal to 0. So either x minus 3 can be 0, or x plus 7 can be 0. So that's going to leave me, when I solve the first equation, I'd have to add 3 to both sides, so that's going to leave me x could be 3 for one of my answers, and on the other one I'd have to subtract 7 from both sides, so that would be negative 7. So now, what if on number 15 I'm set equal to 0? Great. So now I have x squared minus 10x. Well, x squared minus 10x, I definitely have a GCF, so I want to factor that out first. They both have an x, so x, and I'm left with x minus 10 equals 0. So either x could be 0, because that's one of my factors, or x minus 10 could be 0, which means when I add 10 to both sides, I get 10. So that one wasn't so bad. Let's see here. 16 looks like a very similar problem. Factor out an x again. Either x can be 0, or x plus 12 can be 0. I'd have to subtract 12, so that would leave me with negative 12. But look at this last one. It looks a little bit different. We'll move it over here so we can see it a little bit better. X squared equals 25. Well, in order to use the zero product property, I have to have it equal to 0. Not a problem. Let's just make it equal to 0 by subtracting 25 from both sides. That's going to leave me x squared minus 25 equals 0. hopefully you recognize that that's a difference of squares. There is no GCF, it's not a trinomial, that is a difference of squares, which we know breaks down into two terms that start with x and x, and they have 5s, and one's a plus 5 and one's a minus 5. So either x plus 5 equals 0, or x minus 5 equals 0. So I would have to subtract 5 from both sides on this little mini equation, and I'd have to add 5 on both sides of this little mini equation. So we did 4 examples, one that we just did the FOIL method, we did 2 that had greatest common factors, and this last one actually ended up being a difference of squares. So now, here's another type of problem that you might see, and later on we will actually discuss this more, and when you move into college algebra you will really discuss this idea. So this one says find the x-intercepts for the graph of the equation. X-intercepts is where your graph is crossing the x-axis, and then they give you an equation right here. Where it's crossing the x-axis, all we have to do is solve the quadratic, and that will give us our x-intercepts. So all you have to do is take the equation. We're going to replace the y with 0 because at the x-intercept, what is your y value? I know we don't have a specific coordinate listed, but when it crosses the x-axis, your y value is 0 at that point. And now we solve this quadratic equation. And luckily we can solve it by factoring. And you will learn another method later, but it will factor. Factors of 8 that combine for 2, so that would be 4 and 2. And in order to get a negative 2, my 4 would have to be negative and my 2 is positive. You can always check your signs by foiling it back through. So if you're not sure where those signs came from, foil it and you'll see exactly where they came from. And now set each factor equal to 0. Either x minus 4 equals 0 or x plus 2 equals 0. So this would be 4, because I'd have to add 4 to both sides, and this would be negative 2, because I'd have to subtract 2 from both sides. So my x-intercepts, where it's crossing, we could write those out. So my x-intercepts are 4, 0 if we wanted an ordered pair, and negative 2, 0. And that would be my final answer.